Good morning, afternoon, or evening, wherever you may be. My name is Dr. Dominik Konkolewicz,
And I'm Dr. Rick Page.
and we're here to sort of talk about a new series that we're developing, which is on applications of polymers in healthcare and in general settings that we might encounter. So, topic of today's presentation is on personal protective equipment and specifically gloves. So we'll be talking about some different types of gloves and why polymers are particularly useful for making robust gloves. So personal protective equipment, or PPE, has been critical in healthcare, not only recently during the COVID-19 pandemic, but also for the past hundreds of years, right? We can think of lots of examples. For instance, blacksmiths or even alchemists, used to wear gloves of leather when, handling hot metal, right? So this is a way of protecting themselves against, challenges they might face, like hot, pieces of metal, which would otherwise burn the skin. Really, breakthrough in this sort of area really started in 1970s, which is when the occupational health and safety regulations have mandated the use of PPE in professional settings, right? That really changed the way people think about PPE and the necessity of PPE for a safe work environment, be that in labs or be that in, healthcare settings. As we may imagine, early versions of PPE involve natural or minimally modified materials such as leather or wool, and those, may not have been optimized for a particular application.
So in comparison to early versions, modern PPE uses combinations of synthetic chemistry and also biological inspiration and natural components to make really effective and highly engineered materials for more robust performance.
In particular, synthetic polymers feature prominently in modern PPE and medical applications.
So in the following series of videos, we will explore where polymers are used in modern healthcare, in PPE applications, and why they're so effective. So to start the series off, we will explore polymer materials used to make gloves. We will focus on two types of gloves commonly used in healthcare settings, as well as laboratories where significant contact with hazardous substances are encountered.
Yeah, so the two most common types of gloves used in laboratory and healthcare settings are either made from natural rubber latex or nitrile rubber. So this is a nitrile glove. It's commonly colored either blue, purple, black, indigo colored, but the actual starting material is actually a very pale yellow, and they actually put a dye in. So this is a very elastic, tough material.
In comparison to natural latex rubber glove, which I'm holding up here, you can see, is almost quite always sort of this white or sort of pale yellow color. And if you actually take a single layer of it, is fairly translucent. So the question we're going to ask today is, are these gloves interchangeable, or why do we have two types?
And what are these two gloves made of?
So while there's similarities in the underlying components of these gloves, there are some noticeable differences. Both types of rubbers are based on polymers, or these are long chain molecules containing hundreds to thousands of repeating smaller units, a bit like a chain or a beaded necklace. Natural latex rubber, which I'm showing here, is primarily made of a polymer of cis isoprene. So in thinking about that, I have a structure here of isoprene, you can see, and when it's polymerized to form poly-cis isoprene, which you see by the indentation here, what you get is one of the main polymers or main components of what we have here for natural rubber latex. Now, natural rubber is actually obtained from a rubber tree that's grown in tropical climates, commonly Malaysia, Indonesia, and Thailand. And this is about where 70% of the total latex supply comes from globally.
So on the other hand, nitrile rubber is actually a copolymer, meaning that it's a polymer, so again, a big chain molecule, but it's made up of two or more components, a bit like a necklace containing different colored stones in it. Nitrile rubber is a copolymer of acrylonitrile and butadienes. And so we sort of have these structures here. We have 1,3-butadiene here, which has these two double bonds here in this otherwise hydrocarbon molecule. 1,2-butadiene, as well as acrylonitrile here, which is the group shown in blue there. When we combine those components together and polymerize them, we make a long chain molecule which contains all of these different components in it. And that's what we've represented here with this red component, which comes from the 1,3 or the 1,2 butadienes, as well as the blue component out here, which is from the acrylonitrile. And that slash there is to represent that it's actually a copolymer. It's made up of a random, insertion of the blue represented acrylonitrile and the red represented butadiene molecules throughout the long chain molecule. Butadiene is very commonly used to make elastic materials. So we'll see that in lots of other, rubber-like or elastomeric type materials. So for instance, golf club grips are also made out of very often a polymer containing butadiene. While acrylonitrile is used to make things like acrylic fiber. Okay, so synthetic sweaters are often made up of acrylic fibers, which contains a lot of acrylonitrile in it. So when we combine, the butadiene and the acrylonitrile, we get sort of synergistic and hopefully better properties in the individual components. In particular, the butadiene, like we mentioned, is often used in elastomeric type applications, materials that are going to be very stretchable. And in fact, the acrylonitrile provides the excellent tolerance to chemicals. So typically a nitrile glove like this one here might have at least 33 or more % of acrylonitrile in it to get that.
So Dominik, we've used a term here a couple times that the audience might not be completely familiar with, and that is rubber, actually. So what exactly is a rubber?
So really, most broadly, a rubber is a material that's going to be tough and elastic, right? So we want it to be able to be relatively stretchable and adaptable to the surface. So if we put it on our hand, we want it to conform to the shape of the hand underneath it. And we want it to be tough so that it can actually withstand, quite a bit of, stresses and challenges that we might throw at it. So a rubber might not be as strong as, say, a rigid material like glass or concrete, but it's far more elastic, stretchable, and tough.
That's a great answer to that. And maybe we can dig in a little bit more to that. What exactly do we mean by tough?
So basically, a tough material can take a lot of energy and dampen it, store it, or dissipate it without being permanently damaged. And that's something we really would want in a glove. We want it to be able to take, some kind of stretching, some kind of deformation, and not become permanently damaged. We really need that in a glove for it to work properly. We need to follow the movement of the hand underneath them, right? And we can't have it, become permanently damaged if we bend our fingers, or if, in fact, we encounter a relatively pointy or sharp object, we can't have it chip and fall apart. The other materials we mentioned, like concrete, might be stronger than a rubber, but they're not flexible and they may be a lot more brittle, meaning if we have a little chip in them, the material might lose its performance.
Of course, there are a lot of other rubber materials. We find these lots of places, as you mentioned, golf grips. You also find these in balloons. But one thing to think about for the audience is, can you imagine a glove that's made of glass or styrofoam, something that may be more rigid, but something that wouldn't work very well in terms of conforming to motion, really being something that's more elastic and able to respond.
So how do we choose which glove to use? What are the good, the bad, and the ugly of all these different types of materials?
Right. So let's start with the natural rubber latex glove. So it is more elastic than nitrile. It is also more tactile and sensitive. So it's better in applications where, let's say, the sensory aspect or the tactile aspect is critical for the task being performed. Natural latex also becomes significantly stronger and stiffer as it's stretched. And so what I'm going to do is I'm going to take this glove and hold up to the screen and actually really stretch it out. And one of the things you can see here is there's actually this sort of whitening here, this change in color. And this is actually occurring because the individual molecules within this polymer are actually interacting with each other, and they're forming these small crystal domains. And this actually increases the strength and the stiffness of the material as it undergoes that stress, which is a really important property. And this makes natural rubber really perform better in high demand environments, such as the ones where the material is undergoing a lot of stretching, or perhaps it's being impacted or stressed heavily. So given that it has all these great properties, right, you can stretch it, it can really take all these stresses that we're putting onto it. One of the things we have to do is we have to consider why the natural rubber latex glove might not always be our best option. And so there are some drawbacks of the limitations arising from a product that you make that has a natural origin, right? So without using synthetic chemistry, the material's properties really aren't engineered. You're really using the properties of the material as it comes from its natural origin. So some additional issues include variability due to different crops, poor aging properties, especially with ozone is a problem with latex gloves. Really, primarily the biggest issue with natural rubber latex gloves is the fact that they're not just polycis isoprene. There are also natural components from the natural source from those trees. And those components that are most concerning are the proteins that are really embedded in this rubber coming from this natural origin. So about 8% of the population actually has allergic reactions to the proteins that are found within these natural rubber latex gloves.
Right. I mean, sort of think about the flip side, right? A nitrile rubber glove. Okay, so that's a purely synthetic material. Most of it derives from petrochemicals. So the advantage of being a purely synthetic material is that the properties can be, designed and engineered by the chemistry and the processing processes, right? So we can actually really design different properties by choosing different conditions or different components that we put in. Some of the traditional nitrile rubbers were a little bit weaker than the latex rubber, but of course, with recent developments, in fact, new nitrile rubber can be as strong or even significantly stronger than latex rubber because of this factor that we can engineer the properties due to the fact it's coming from synthetic chemistry. Nitrile rubber doesn't have the same sort of strain stiffening properties, right? As we start straining the material, we don't see it become as white or as crystalline as we do for the natural rubber. And that's that idea of the chains in the natural rubber coming together, forming a crystalline domain. And we don't quite see that same effect in natural rubber. Generally speaking, nitrile rubber, especially due to the presence of the acrylonitrile in the feedstock, really has much better barrier properties against chemicals. So for a chemistry lab or a lab where we're handling a lot of VOCs or other organic components, generally speaking, we're going to want to use a nitrile glove. In general, though, one of the limitations is that the nitrile glove is not going to be as elastic, so meaning we can't stretch it quite as far before it breaks as a natural rubber glove. And of course, one of the other limitations is the sort of environmental one, that because they're from made by synthetic chemistry, not from natural feedstocks, we don't imagine the biodegradability of nitrile gloves to be as good. So that kind of gets us to this question of which one should we choose for a particular application?
And that's a really great question, right? So for cases where the sensory aspect is critical, as we mentioned before, or if you're working just with aqueous or water-based compounds and mixtures, and also that the person does not have a known latex allergy, latex gloves such as these are really an excellent choice. And of course, money also plays a role in the choice that you make, and cost generally favors latex gloves.
On the other hand, when handling complex chemicals, in that case, the better barrier properties make nitrile gloves a superior choice in most cases. And in fact, there's some great charts out there for the specific type of glove you should use against a particular chemical. And we've just highlighted here nitrile gloves and latex gloves, but of course, there's many others out there that have orthogonal barrier properties. Clearly, though, whenever someone has a latex allergy, nitrile gloves are the way to go. So that kind of gets us to back to this healthcare question. Why do we think that healthcare providers have moved to predominantly nitrile?
Yeah, it's another great question. It really has to do with those latex allergies. So with about 8% of the population having an allergy to the proteins that are embedded in these natural rubber latex gloves, nitrile is really a safer option. So if you take an emergency room, for example, there are times where you will get patients coming in the door who are not able to give you a response to the question of do you have a latex allergy or not. So in order to adjust to that, we err on the side of caution and tend to use nitrile gloves as the first choice. And modern nitrile gloves can also be just as strong or sometimes stronger than latex gloves. And this really makes nitrile a fantastic option for most healthcare professionals. So there we have it. We hope that you've enjoyed this video and that you learned something new about polymers and their applications, about the underlying chemical properties of different rubber materials, and how those have an impact on the glove that you will choose. So either natural rubber latex or nitrile. And in our next video, we're going to continue our exploration of polymers in PPE and focus on a topic of international conversation recently, masks. So thank you and see you next time.